Good afternoon, ladies and gentlemen. My name is Justin Coffey, and I'm going to be presenting on behalf of EML 3005 Group 19. This will be our final project. Included in the group is myself, Justin Coffey. To my left, Stephen Cunningham, William Moss, Justin Tennant, and Javier Vives. All right, we'll start off with our dimensional footprint, which is our 2D projection of how much space our design is going to take up on your factory floor. Its width is 0.7 meters, length 2.1 meters. Overall, it takes up a collective space of 1.5 meters square surface area. Regarding our material selection, we originally wanted to make all of our components out of type 304 stainless steel. It's a type of stainless steel that's corrosion resistant, resistant to oxidation in environments such as the food industry where most of the materials are prone to that type of thing. In fact, due to its strength and its cost, we kept most of our components of that material. Our gears and our supports all made of the type 304. Our only exception were the rollers. In interest of keeping them light, we decided to make them out of aluminum instead. Our original rollers were upwards of 200 kilograms each. In order to bring that weight down, we switched over to aluminum. And with a much lower density, the rollers are now each only 26 kilograms.
Okay, our motor, from the 100 Newton axial force from the pasta, the friction was determined to be 20 newtons on each roller, which created a 2 Newton meter torque on the roller. The motor was chosen to output the required 6 Newton meters of force combined by the rollers at 318 RPMs. This output power was 200 watts. Okay, our gears were direct driven from the motor with a pitch diameter of 30 centimeters. The 6 Newton meter of torque was input on one shaft, which was divided between the roller input on one shaft and the pasta on the other shaft. Okay. The bearings were chosen nominal at 30,000 hours. Based on the load calculations, we determined that the catalog load rating of this was 210 kilonewtons required. From this, we went to the Timken website and chose the roller bearing shown here. This roller bearing actually has a catalog load rating of 216, which ups our life prediction to about 36,000 hours. At 16 hours per day is about 5.6 years. Okay, the rollers, the stress prediction on the rollers was assumed based on the stainless steel to a rubber Hertzian contact distribution, since the Young's modulus of the pasta we were pushing through could not be determined. Based on our results, we can assume that the pasta does not, that the rubber does not sufficiently yield the roller, therefore the pasta would not be able to yield the roller.
All right, now regarding our predicted part life for each of our components, I'll begin by addressing the gears. What we did with the gears is we went ahead and we calculated the maximum stress from the modified Gooden equation for that particular material, the 304 stainless steel, and then using the Lewis bending equation for individual gear teeth, we were able to calculate a minimum face width for which anything larger than that we would have an infinite lifespan for our part. It's calculated to be 0.0016 centimeters. Just to have very high factor of safety, we ended up using 2 centimeters as our overall gear width. So therefore, it's going to have an infinite lifespan. The rollers, as Stephen just mentioned, are going to have an infinite life due to the fact that the contact stresses imparted by the noodles are going to be almost negligible. So the rollers will have an infinite life as well. The bearings, as he also mentioned, using the load life equations, it's equations 112 and 116 out of the Shigley book, for roller bearings specifically, and using the catalog load rating for this particular bearing, we were able to determine that it had an approximate life of 5.6 years. And the supports, since all they're holding essentially is the weight due to the rollers, they're under constant static compressive stress, and the loading forces put on those is simply not enough to cause it to yield in that particular situation. So therefore, those will have an infinite life as well. And what we have here is a overall of our entire assembly here. You can see the individual components here as well. I think that about sums it up, concludes our presentation, and thank you, ladies and gentlemen, for your time.